Okay, hey there, Math 1050. So this is your last lesson that you have to learn for the class. It's on section 7.4 and it's titled Dimensional Analysis. I personally love this topic. Sometimes the students don't love it as much, and we don't go too in depth with dimensional analysis in this class. But I am going to give you or provide you a couple of examples of what dimensional analysis is here. Again, I hope you've already looked at the PowerPoints that have been uploaded to Canvas. So let's get started with these couple of examples first. So number one that I've already written down says, how many seconds are in one day? Okay, so we're obviously starting with one day, and we want to know how many seconds. So let's talk about what we know about days and seconds. So hopefully we all know that there's 24 hours in one day. Like, that's true. Hopefully we all recognize that 1 hour is the exact same as 60 minutes. And then hopefully we recognize that 1 minute is the same thing as 60 seconds. Okay, so I just wrote some key ideas that I knew over there because I knew I had to get from day to seconds. Okay, so if I start off, clearly it says we are looking for how many seconds. So this is what we're looking for. How many seconds are in one day? So I make this thing called a t-table when I do this. So I'm going to draw this little t-table. Okay. And up here in the t-table where I'm at, that's where the given goes. And the given here is 1 day. So I'm going to put 1 day right here. Okay. And then what do I know about days in particular? Right here. I know that there are 24 hours in 1 day. Okay, so but I organized my t-table exactly how I need to. So because day was in top or in the numerator on the top, now day is going to go in the denominator. So I'm going to put 1 day in the denominator, and 1 day is the same as 24 hours. So I'm going to put 24 hours in top. Okay, let me say that again. 24 hours right here and 1 day are exactly the same, so I can put them on top of each other because technically they're equivalent. It's just one is in hours and one is in days. They're in different units, okay? And so I'm not sure if you recognize this or not, but when you have a day in the numerator and a day in the denominator, that unit can cancel out, okay? So this day and this day are going to cancel out. And if you notice, I deliberately did not cancel the number. All I did was cancel the unit, so day and day, okay? So we would be done if it asked for how many hours, because the only unit left in my problem in my t-table is an hour. It wanted seconds. So we need to now go from hours to minutes. So we know that 1 hour is the exact same thing as 60 minutes. Again, why can I write that? Because 60 minutes and 1 hour are exactly the same. So I put them on top of each other. And then again, notice I put this in a deliberate pattern. 60 minutes went on top and 1 hour went on bottom. Why did 1 hour go on bottom? Because an hour on bottom and an hour on top will cancel out. And then I'm going to go again because it doesn't want minutes as my final answer. It wanted seconds. And so what do I know about minutes and seconds? I know that 1 minute is equal to 60 seconds. And so again, I deliberately placed this in a particular order because minute is on bottom and minute is on top. So they're going to cancel. And so once you look at this, guys, the only unit left is seconds, which is good because the problem asks for seconds. And so once you get through organizing, guys, it's easy from here. We simply multiply the entire top, aka the entire numerator, which means I would multiply 1 times 24 times 60 times 60, okay? So if I take my calculator and multiply 1 times 24 times 60 times 60, I get 8,640. And then notice we were only looking at the top, so we had 1, 24, 60, 60 seconds. So I'm going to put second with it. And in the denominator, guys, okay, take a look up here. The denominator was just 1 times 1 times 1. And 1 times 1 times 1 is, we know, is just 1. And so in reality, you get 8,640 seconds divided by 1, which is just 8,640 seconds. And so if I back up a minute, some of you may say, well, why wasn't there a unit in the denominator? We put seconds in the numerator, but we didn't put a unit in the denominator. Well, if you take a look back up here at the denominator, the unit canceled out, the unit canceled out, and the unit canceled out. So in this particular problem, there was no unit in the denominator. That's why there was only seconds in the numerator, okay? So there's an example 1, and I wanted that one to be somewhat complex. That way you could get the hang of units in the numerator and units in the denominator. So let's take a look at number 2. I'm a big runner, and number 2 says, if I ran 5 kilometers today, how many miles did I run? And so we have to know a conversion between kilometers and miles. Okay, so usually my math lab will give us a conversion from kilometers to miles, but I can tell you that 1 kilometer is equal to about, guys, this is not exact, 0.63 kilometers. Okay, so that's a rough estimate. It's not exact, but if we take a look there, let's reread this problem. It says I ran 5 kilometers, so we're going to start with 5 kilometers, and part A says how many miles, so we're looking for miles. So if I start my t-table again, okay, the given always begins, and what were we given? We were given 5 kilometers, so right up here I'm going to put 5 kilometers, okay, and then, oh, look over here, I made a mistake over here, guys. 1 kilometer, when I was writing down the conversion, 1 kilometer is equal to 0.63 miles, okay, so I wrote that incorrect. Okay, so we know that 1 kilometer equals 0.63 miles. So when I come over here and I write in my my units, I'm going to put 1 kilometer in the denominator and 0.63 miles in the numerator. And most of you probably know from the last example, I deliberately did this placement because kilometer was in the top and now kilometers in the bottom, so they're going to cancel out, okay? And now, guys, in the last problem, we had to keep converting, but this was a one-step conversion because now we're literally already in miles, and I wanted to be in miles. So I just take my calculator again and multiply the numerator, and the numerator is 5 times 0.63. And so if I button push over here, 0.63, I get 3.15. So 3.15. And if you take a look again, what unit was left in top? The only unit that was left was miles. And if we take a look at the bottom again, guys, the only unit that was in the bottom, right here, was 1. So technically this is divided by 1. And we all know that 315 or 3 decimal 15 divided by 1 is still 3.15 miles. And that's true, guys. Like, I knew that off the top of my head because when I run 5 kilometers, I know I'm running around 3.15, somewhere in there, miles. So that is completely true, okay? And so part B now wants me to know how many feet did I run. Well, think about it, guys. You already know that you're in 3.15 miles. So that's the new given. You got that from part A. And hopefully, over here, if I write down the information we need, hopefully you know that 1 mile equals 5,280 feet. Okay? So 1 mile is equal to exactly 5,280 feet. So if I set up my t-table, I'm going to put 1 mile in the denominator. Again, if I put 1 mile in the denominator, mile and mile will cancel eventually. And then 1 mile over here is equivalent to 5,280 feet. So I'm going to put 5,280 feet up here. And mile is going to cancel with mile, exactly like we thought. And so I'm simply going to multiply the numerator, 3.15 times 5,280. And if you want to set it up like this, you can go and put it over the denominator. And the denominator again is just 1. So 3.15 times 5,280 is 16,632. Again, please put units, the unit that we're looking for in this particular problem, and the one that's left is feet. And that's what the problem asked for, was feet. So we know we're finished. Okay? Okay, and so now I'm going to go in. Usually when I teach this class, I have a wrestler in the class. So I'd like to do this example because wrestlers have to meet weight when they have their meets. And so number 3, it says a wrestler weighs in at 146 pounds. How many kilograms does he weigh? So I went on and wrote down a couple of conversions because, in all honesty, guys, I don't have these conversions memorized. My math lab will give you a couple of conversions on the problems, and you have to pick which conversion is appropriate for that particular problem. Okay, so if we take a look at the problem again, the wrestlers weighing 146 pounds. Okay, and the question wants to know how many kilograms. So if you take a look at the information that I gave you, this is conversion 1, this is conversion 2. Okay, conversion fact 1 and conversion fact 2. Take a look especially, this is conversion fact 1 and conversion fact 2. Take a look at conversion fact 2. Conversion fact 2 discusses pounds and kilograms, and our problem also discussed pounds and kilograms. So that is the conversion factor that we need to use, okay? So let's get started. Draw your T-table, okay? And if you've ever taken a chemistry or physical science class, guys, this T-table should be seen before. You should have seen this T-table before because you do a lot of conversions in science classes. That's one of the reasons why I like to keep this lesson in this unit, because this is very, very beneficial for other classes, okay? So getting back to the problem, the given was 146 pounds. That wrestler weighs 146 pounds, okay? And if you look at the given, it says 1 pound equals 0.45 kilograms, so 45 hundredths of a kilogram. So 0.45 kilograms goes on top. Again, why did I do that? Because pound on bottom and pound on top is going to cancel. And if you take a look, what unit is left? Kilogram, and that is good because the question up here asks for kilograms. So all you need to do is multiply the numerator, okay, and the denominator. So I'm going to multiply 146 times 0.45. That's what's in the numerator over a 1 again, okay? So 146 times 0.45 is 65.7. 65.7 over a 1, and 65.7 over a 1, which means divided by a 1, is 65.7. Put your unit, what unit was left in the problem, kilogram, and so it is kilogram. And so I don't have the weight classes memorized, but I think there's a weight class at either 65 or 66 kilograms. So if that guy, if this wrestler weighed in at 65.7 kilograms, that would actually be really bad because he would be too heavy if it was 65 kilogram weight class. But anyways, that's the conversion factor and the problem. Okay, so let me tell you one thing I noticed about all of these problems that I gave you. All of these problems, so problem 1, 2A, 2B, and number 3, all had 1 in the denominator. 1 will not always be in the denominator. It is a lot of the time, guys, but it is not always. So, for example, I'm going to make up one more problem. What if I said, let's do, 2,000, let's convert 2,342 centimeters to feet. Okay. So really, really straightforward. We know, what do we know about feet and length? We know that there are 12 inches in a foot. Okay, that's pretty common knowledge. What may not be as common is that 1 inch is roughly 2.54 centimeters. Okay, so those are some conversions. So let's get started. Our units is 2,342 centimeters. That was our given. Okay, and so in order, what needs to go down here, guys? Well, obviously centimeter needs to go down here, because if there's a centimeter in the bottom and a centimeter in the top, it's going to cancel. And so if I come over here and look at my conversions, I know that 2.54 centimeters equals 1 inch. Okay, so centimeter is going to cancel with centimeter. And if the problem asks for inch, I'd be done. But now I need to know if inch is in top, then inch needs to be in the bottom. And so there's 12 inches and 1 foot. And so then inch and inch are going to cancel again. So if you multiply, the numerator is 2,342 times 1 times 1 over the denominator, which is 2.54 times 12. Well, 2,342 times 1 times 1 is just 2,342. 2.54 times 12, guys, is 30.48. And you may say, well, Miss Flo, what do I do with these two numbers? Well, you divide them, guys. That's a fraction. So 2,342 divided by 30.48 is roughly, so that's approximately, for those of you that aren't aware of that symbol, 76.8. And then put the unit, guys. What's the only unit left up there? Feet. So we put feet. Okay? So if for some reason, some strange reason, you had 2,342 centimeters of yarn, that will be 76.8 feet of yarn. Okay? So I wanted to give you one